And again, feel free to just put A or B. All right, moving on to number 2. Again, I'll give you about 30 seconds for this next one. All right, we're going to go to number 3. I'll give you a little longer because this one's a little bit longer to read. Give you maybe 10 more seconds on that one. All right, moving on to number 4. I'll give you about 30 seconds for this one. About 5 more seconds. Okay, moving on to number 5. All right, number 6. Number 7, I'll give you just a little bit more time on. Here's number 7. This one you do not have like an A and B, so you can write down as many of these cards as you want. So you might just have 1 all the way up to 4. So again, with this one, write down as many of the cards as you think. You might write down all 4. You might write down 1 of them. Do 2 or 3. Give you about 5 more seconds on that one. All right, question 8 is pretty long, so I'm just going to kind of keep an eye on the room and see when it looks like everyone has answered it. So here's number 8. And your answer for this one basically should be a percentage between 0 and 100%. between 0 and 100%. Give you like 5 more seconds. Okay, number 9 is going to be quite a bit different than the rest. For number 9, it's more important than any of the others that you don't share your answers with anyone. So no talking, and also maybe try to kind of like block your answers if you're close to a neighbor. So number 9, I can just kind of describe this. So I have a rule that I'm using. I'm thinking of a rule for listing numbers. This sequence follows the rule, 2, 4, 6 does. So on your paper, I want you to write another sequence of 3 numbers that is following what you think the rule is. So you're trying to figure out what the rule in my head is. Write a sequence of 3 numbers that you think follow that. I will come around to each person and tell you yes or no if it fits the rule or not. And then you can do that as many times as you want. So, you could test as many number sequences as you want to until you think you know what the rule is in my head. Once you think you know the rule, just write it down on your paper, and then we'll move on from there. Does that make sense? Okay, so write down your number sequence. I'll come around and look and tell you yes or no. Yes. 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 Again, don't show your answer to anyone. Yes. 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 Yes or yes. Yes. Okay. Yes. 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 No. Is there anyone who wants a second sequence? Or is yours? Yes. Once you think you know the rule, write it down. Anybody want me to look at another one? Okay, so we're going to move on. I want you to hold on to that scratch paper or Word document or whatever you used, because we'll come back to it throughout kind of the lecture today. So I will say some of those had a correct answer. Some of them, you could kind of argue what the correct answer is, but that's not necessarily the point. But we'll get to each one. And I'll tell you kind of the point of them. So again, I really need to rename this lecture. It'd probably be better to call it something like heuristics and biases. Because the main thing we're going to talk about today are the different cognitive biases that often get in the way of our thinking and problem solving. So just quickly, a heuristic is basically like a shortcut that our brain uses to try to figure out the world. And a lot of times these heuristics are accurate and helpful, because they're very fast and they allow us to just quickly make decisions about complex material. But they can also often go wrong. So sometimes, we can have issues that we run into because of these heuristics that kind of lead us astray because of these various assumptions that we make. I should also mention it's possible, I should have checked the PowerPoint before I started, but I think the one on Canvas are you guys
solving an intelligence.
Yeah, do you guys have an extra slide before this one? I can't remember. I feel like there might have been some slides that I deleted and then.
Just a different title.
Okay. All right, so hopefully it all lines up. I know I edited it at some point and I can't remember if I updated the one in Canvas or not, So we're going to talk about a few of these different heuristics and go through them kind of one at a time, and then I'll point to some of the examples that we just went through. We do have examples for some of these, but not necessarily all of them that we just completed. So the first heuristic is called anchoring and adjustment. And anchoring and adjustment is basically this heuristic that we use whenever we're making decisions about numerical quantities, basically. And it works basically where if you get a number first, your mind sort of anchors to that number and uses that as sort of like your base point to compare all other numbers to and adjust based on that. So we had 2 questions in our example that kind of fit this anchoring and adjustment. One of them was about the redwood tree, like the height of it, and the other one was about the population in Brazil. So I have a graph here. So these graphs that I'll show throughout, these are the answers that are typically given in questions like these. So all these questions that I gave you, I pulled from like studies that have been done using, participant samples, like 100 participants in each study. And these are kind of the common answers that people usually give in response to these questions. So first we're looking at question number 2 versus question number 6. And they would have actually been made up of a couple questions. So I think it was question 1 and 2, where it asked about the height of the tree. And then it would have been question, I think, 5 and 6 that asked about the population. So the first one asked, do you think the height of the tallest redwood tree in the world is more or less than 1,000, is what it asked first. So it asks, is it more or less than 1,000 feet? And then the second question is it more or less than 400 feet? So basically what your brain does, when you get that first question of 1,000 feet, your mind kind of anchors on that. And all of you probably know, like, a sequoia tree is not going to be 1,000 feet. That's ridiculously tall. And so that's a really high number. So you probably said less than 1,000 feet for that first one. But then for the second one, your brain is kind of anchored to that 1,000. So then 400 in comparison doesn't seem so big. So probably most of you said that the sequoia is more than 400 feet. So that would have been question number 2. If you put A for question number 2, then you would kind of be fitting this graph. So you can look at your answers real quick. That would be number 2. If you put A, then that's more than 400 feet. In reality, the tallest tree is about 380 feet. How many of you, just out of curiosity, how many of you said it was more than 400? I'm always a little wary because, this is one of the first times I've done this question in like the Pacific Northwest. All of you probably know a lot more about redwoods than like the students I had in Iowa. So I thought maybe some of you might have actually known, like off the top of your head, what the tallest one is, but no. So yeah, so everybody get what I'm saying there? You anchor to the 1,000, and then because of that, 400 doesn't seem so big, so you think it's got to be bigger than 400. Then with the one asking about the population of Brazil, it's kind of the same thing, but in reverse. So it said, Brazil is the largest country in South America. Is the population more or less than 1 million was the first question. 1 million, very small number for a population of a country, so you probably said more than 1 million for that one. But now your brain is anchored to that number. So in comparison, 100 million sounds really big. So probably most of you said less than 100 million for that one. So that would have been question number 6. And if you put B, that would have been less than 1 million. Or 100 million, sorry. So again, how many of you said B on number 6? Okay, you, not everybody, oh yeah. So again, you're kind of anchoring to that 1 million is a small number, so then you think 100 million is big in comparison. In reality, Brazil's population is 212 million. It's probably even bigger than that now, because I pulled that number, I don't know, at least a few years ago. So I would assume that they've grown since then. So again, you're kind of anchoring to a particular number. Can anybody think of like a real world scenario where you might be maybe manipulated by this bias? Think of a time where maybe like you see a number that makes you think like, oh, that's really big or that's really small, and then it's sort of adjusted from there to change your perception. Yeah.
Would it be like when you're buying stuff?
Yeah, so if you go buy anything that's like discounted, right, and it shows you the original sales price was $200, but now we've marked it down to $100, right? In reality, that thing was probably never on sale for $200. They were never going to sell it for that much. They always intended to sell it for $100, but they make you think it was going to be $200 because that sounds like a lot. So in comparison, 100 sounds like a really good deal. So it's basically tricking your brain into thinking you're getting a good deal whenever you're not. So anytime you see like a sales tactic like that where they're showing you the original price and the discounted price, they're almost always using this to manipulate you into buying something because you think you're getting a good deal. So that's anchoring and adjustment. The next one is called the availability heuristic. So availability heuristic is basically this kind of mental shortcut that we do. If we're asked about a probability of something or the likelihood of something occurring, we often will try to remember the times that that thing has happened in the past. And if it's easy to remember, if that memory is available to your mind very quickly, then you're going to think it's a high probability. But if it's hard to remember something or it's hard to think of an instance of it, then you're going to think the probability of it is pretty low. And so again, keep in mind these heuristics, a lot of times they're really useful. So most of the time, if you can think of lots of instances of something happening, then it probably happens a lot. So there's probably a high probability of it. So it's a good little mental shortcut your brain can do. But there are lots of times where it'll kind of lead us astray because there are a lot of factors that can contribute to how available a memory is that has nothing to do with like the probability of that thing happening. So the example we did just now that corresponds to this was question number 4. So this is the one asking, if you take a random word from the English dictionary, is it more likely that it starts with K or that it has K as the third letter? I think, let's see, so for question A, or for question 4, A would have been first letter, and then B would have been that K is the third letter. So how many of you said it's more likely that K would be the first letter, which was A? Okay, quite a few of you. So that's kind of the common response that you get. So most people will say that it's more likely you're going to get a word that starts with the letter K. And part of the reason is that it's much easier for us to think of words that start with a letter than it is for us to think of any word that has like, you know, a particular letter in the middle or even at the end. And that just has to do with the way that our brain sort of categorizes vocabulary. Like our brain, when we're storing words, is almost like a dictionary where we have them sort of sorted in alphabetical order. So it's very easy to kind of call up, like, okay, I'm going to think of all the words that start with K, but it's not easy to think of the ones that have K as the third letter. I've tried to find the correct answer for this one. It's a little more tricky than you might think it would be, but it seems like probably it's likely that there are more that have K as the third letter. Or at the very least, they're pretty equal. They're like really close to being about the same number of words. Could any of you think of a word that has K as the third letter?
Yeah.
Ask. Yak, would that have, yeah, I guess. Because there's no C in there, right? I was thinking Y-A-C-K, but I guess this is Y-A-K. Okay, any others?
Cake.
You say that again, cake?
Cake.
Yeah.
Okay.
So once you stumble on a word like cake, then that kind of unlocks this part of your brain that's like, okay, you've got cake, then there's bake, take, rake, fake, right? You can start thinking of words that rhyme with that have the third letter. So if you happen to think of one of those words very quickly, then you're maybe more likely to go with the third letter as K, because now you've got this whole like rhyming scheme that you can use to unlock a bunch of words that most people wouldn't have thought of to begin with, right? So if you thought of one of those, you might have put B, but most of the time we're just going to go through and think of like lots of words that start with K. If I asked you all to list words that start with K, we could probably be here for like an hour just listing off words without stopping, because again, it's really easy to think of something that starts with a letter, but hard to think of something where the letter's somewhere else. So availability heuristic. Anybody think of any real world examples of this one? This one's maybe a little more tricky to think of, but once I tell you some examples, you'll see it everywhere. But let's just see. Can you think of one? Think about like news headlines. Anybody know where I'm going with that? So think about like, let me ask you another question. What do you think is the most dangerous occupation to have? And by dangerous, I mean like you have the potential to die. Any guesses, Aiden? Underwater welding, okay. Any other guesses?
I would probably say a politician.
Politician, interesting, like assassinations or something is what you're thinking of?
Yeah.
Okay. Any other guesses?
Firefighters.
Firefighter. So that's the answer I was expecting, was like firefighter or cop. Those are the most common answers people give. Underwater welding is interesting. Is that like an occupation around here? Because I feel like my last quarter someone also said underwater welding, and it's like something I've never even thought of. Like obviously there must be people who do that because their structure's underwater, but I had never like heard of it before coming here. So it's like maybe that's an occupation. It's kind of like common around here. But most people are going to say cop or firefighter. Why do you think most people would say cop or firefighter when you ask that question?
Do we see it on the news?
Yeah, exactly. Most of the times that a cop or a firefighter dies in the line of duty, there's going to be a headline about it. It's going to make at least like local news, potentially national news. I have never heard of anyone dying doing underwater welding. I'm sure it happens all the time, but it's not going to make the news, right? In reality, the most dangerous occupation, if you look at like per capita, like you take the amount of people who work that job and the proportion of people who die from it, is actually logging. So like being a lumberjack, cutting down trees. Is one of the most dangerous occupations. But again, that's one you never really hear of. You guys might hear about it around here because logging is a super common industry, so it might make the local news. But most people in other parts of the world where that's not a super common occupation, they're never going to hear about those things happening. So things that we hear about often in the news, we start to think like, oh, that must be really common because I hear about it all the time. But really it just has to do with like kind of the emotional nature or even political things going on that make those things make the headlines. And you could think about that with anything like dying in an airplane crash, right? It's very unlikely that you're going to die in an airplane crash. You're much more likely to die in a car crash. But a lot of people are terrified of going on a plane because they hear anytime a plane crash happens and people die from it, it makes national news, maybe even international news. So we hear about it when there's, thousands of car wrecks happening every day, people dying from it, but not all of those are going to make the news because it happens so often, like the news couldn't report on all of those. So we get this kind of warped view of what's common just based on what we hear in media, news, etc. So that's the availability heuristic. Next one, these next couple I don't have examples for, mostly just because they would take kind of a little bit more setup. They're not something I can do in just like 30 seconds. One of them is called the familiarity heuristic. So basically this refers to the idea that if we see something that feels familiar to us, we're more likely to like that thing. We're more likely to accept it or enjoy it. So this one is used all the time by companies, basically like branding. You can think of as the most common way of using this familiarity heuristic. So like right now, I look out in the room, I see tons of little Apple logos. And every time I see that Apple logo, I'm getting more and more familiar with it. It's more familiar to me because I've seen it a bunch of times. So then if I'm trying to make a quick decision, if I gotta go buy a new laptop or a new phone, if I wanted to take the time to really sit down and think about it and ignore these heuristics, maybe I would make like a spreadsheet and have like every laptop I can think of and list out the price and how much memory it has and et cetera, and like make a really rational decision. But if I'm pressed for time, if I have to pick something really quickly, I don't have time to sit down and do that, this familiarity heuristic is going to kick in, and it's going to say, oh, you see Apple logos everywhere. That feels very familiar, so it must be good, so I'm going to buy that one. That's the main reason companies love to stick their logo on anything possible, because the more exposure they get, the more people get familiar with that, the more likely they are to purchase it or to enjoy it or like it. The affect heuristic is kind of similar, just a little bit broader. So affect heuristic is basically just making decisions based on how something makes us feel emotionally, instead of using like a logical, rational, slower process to make that decision. And it's especially true if you're basing your decision off of current emotions that have nothing to do with the decision you're making. So maybe you're really frustrated and angry because of something that happened at work, and then that affects the decisions that you're making outside of work that have nothing to do with what caused that original emotion. Or maybe you're really happy, you're in a great mood because of something that happened, at school or whatever, and then that happiness influences the decisions that you make outside of the thing that made that emotion in the first place. So again, it's making decisions based on emotions, especially emotions that are irrelevant to the actual decision that you're making. All right, the next one is called the representativeness heuristic. And this one refers to this idea that it kind of relates back to what we were talking about last time with like schemas and stereotypes. This idea that we have kind of a prototype of things, and that if something seems to fit that in even one way, then we often will think that it fits it in every way possible. Okay, let me give you the example we did, and it'll make a lot more sense. So this one was relating to this paragraph I gave you about Kristen. So Kristen is this 31-year-old. She, is very active politically in things like the Women's March, etc. And I told you to choose how likely is it that she's either a bank teller or how likely is it that she's a bank teller and a Democrat. So I think bank teller and Democrat would have been A in that question, if I remember correctly. So how many of you, and that would have been, let's see, question 7? Maybe I have this wrong. I think I got it wrong in my notes. Do you guys remember? Because in my notes I say question 3, but up here I say question 7.
I think it's 6.
Was it? It might have been. It's probably 7 if it was like more towards the middle.
7, you have like options of cards.
Okay, that was, yeah. I think I have them out of order in my notes then. Well, maybe you remember. So how many of you remember if you said bank teller and Democrat? How many of you said that? Okay, and how many of you said just bank teller? All right. So logically, if we think about this, right, like if we have kind of a Venn diagram of people who are bank tellers, and I'll do 2 colors here. So these are people who are Democrats, and these are people who are bank tellers. And then this little sliver are the people who are bank tellers and Democrats, right? So just mathematically, it's much more likely that she's a bank teller than it is that she's a bank teller and a Democrat. Everybody see that? So if you just stop and think about it mathematically, the correct answer would be that it's more likely she's just a bank teller. But the reason most of you probably chose that she's bank teller and Democrat is because there's nothing really in the paragraph that describes her being a bank teller, but there's lots of things that might lead you to believe that she's more, politically democratic, she's into social justice, she did the Women's March, etc. All things that we think represent being a Democrat. Okay, so this is the representative heuristic because basically Kristen has these few little bits of information you know about her that are representative of being a Democrat, and based on just that one tiny little paragraph of information, your brain assumes, well, she must be a Democrat because she checks off these few little boxes, right? And then from that, you make kind of an irrational conclusion that she's probably bank teller and Democrat because I know she must be a Democrat. Does that make sense? But again, just mathematically, it's much more probable that she's just a bank teller. And maybe she's a Democrat, but maybe she's not. Who knows, right? So representative heuristic, often when we meet someone and that person has just one quality that represents something to us, then we often will jump to this conclusion or make an assumption that they must be that thing. All right, the next one is called confirmation bias. So confirmation bias is it's kind of similar to representative heuristic, but again broader. Representative heuristic mostly applies to people. When you meet a person, you know something about them, that makes you think they are a certain way. Confirmation bias is much more broad. So confirmation bias is basically where you get an idea about something, or you think you know something, you think you're right about something, then you often will only seek out information that confirms that thought, and you'll ignore anything that disproves that thought. So the example for this one, well, there's a couple of them. First was question number 7. So this was the one with the cards. So if you remember, I'm trying to remember what the cards were and what the rule was. I want to say it was ER 8 and 5. Does that sound right?
ER.
Yeah. So those were the 4 cards you had, and the rule said that if there's a vowel on one side, then there must be an even number on the other side. And so then the question is, which of these cards do you have to flip over to see if that rule is true? Most people are going to say E and 8. How many of you put that as your answer? A few of you. Okay. Did anybody say E and 5? 2 of you? Okay. What else did people put? I'm just curious. You don't have to tell me, but anybody can put something different. So some of you put all 4 of them? Okay. Anybody put
E8 and R.
E8 and R. Okay. So let's stop and think about this a little bit. So the rule says if there's a vowel on one side, there has to be an even number on the other side. So we probably all correctly guessed you definitely got to turn over E. Okay? Because E has a vowel. So if I turn over E and there's an odd number, then I've immediately disproven the rule. Okay, so we definitely need to turn over E and see if there's an even number there. If I turn over R, does it really matter what's on the other side of R?
It's not a vowel.
No, it's not. It's not a vowel, right? It's a consonant. The rule says nothing about consonants, so there could be a picture of an elephant, there could be an odd number, an even number, it doesn't matter, because the rule says nothing about consonants. So there's no reason to turn over R. Okay, what about 8? This is where things get a little bit tricky. If I turn over 8, and there's a vowel, then that supports the rule, right? Well, what if I turn over 8 and there's a consonant? Does that disprove the rule? Doesn't, right? Because again, the rule doesn't say anything about consonants. It says if there's a vowel, there has to be an even number, but it doesn't say that even numbers can only be with vowels, right? So if I turn this over and there's a consonant, that does not disprove the rule. So turning over 8 doesn't give me any additional information, but it will give me information that makes me continue to think I'm right. Does that make sense? So even though 8 is actually irrelevant, our brain sort of tricks you into thinking, well, if I turn over 8 and there's a vowel, then that's helping to kind of support this idea that I already have, that vowels have to have even numbers. So that's confirmation bias kicking in if you want to turn over 8. But really what you need to turn over is 5, because if you turn over 5 and there's a vowel on there, on the other side, then that does disprove the rule. Because now you have a vowel paired with an odd number, and it says a vowel has to be paired with an even number. So the correct answer to the things we need to turn over are E and 5. Does that make sense? This is a little bit easier to understand if you apply it to something concrete, like a real world example, instead of making it abstract. So let's say the rule, instead of saying if there's a vowel, then you have to have a even number. Let's say the rule is that if you're drinking alcohol, you have to be over 21. Okay, so let's think of the cards that way. So on one side of the card, there's a beverage that's going to be either alcoholic or not. And on the other side of the card, there's an age. Okay, so let's say here we have a 16-year-old. And then on R, we have a soda. And instead of 8, we could have a 30-year-old. And instead of 5, let's have vodka. Okay? So now let's say you're a bouncer at a bar, and you've got to check who's obeying the rule. In that case, which cards are you going to turn over? Are you going to turn over the 16 to see if there's alcohol in the back? Definitely, right? If there's a 16-year-old, we want to make sure they're not drinking alcohol, so we're going to turn that one over. Do you need to check if you see a person drinking soda? Do you need to check what age they are? No, we don't care, right? That's irrelevant. Okay, if someone's 30, they're clearly over the age of 30, do we need to check what they're drinking? No, right? Because whether they're drinking vodka or soda, it doesn't matter, because they're over 30, so who cares? If someone's drinking vodka, we're definitely going to want to check their age, right? We're going to want to check and see, are they over 21 or under 21? So it's the exact same setup. I've just taken this abstract letters and numbers and turned it into something real world, ages and alcohol, and all of a sudden it makes a lot of sense, right? So often we turn to these heuristics whenever we're rushed for time and we have to make a decision really quickly, or if something's really challenging and our brain just doesn't want to deal with it. Our brains by nature are very lazy. They like to take the easy way out anytime that they possibly can. So if we're faced with something like this that's abstract and challenging, our brain is I'm just going to resort to this heuristic. I'm not going to stop and think about it. But if it's something that's pretty simple and straightforward, then we're often a lot better at making rational decisions. Another maybe more straightforward example of confirmation bias was the last question, where I had you try to guess the rule. So first of all, anybody want to tell me what they think my rule was? How many of you think the rule is that I was counting by even numbers? 2, 4, 6, 8, 10, 12. Okay? Those of you who didn't raise your hand, what do you think my rule was? Anybody?
I thought it was just +2 for whatever number you started with.
Yeah, so that'd be kind of the same as what I was saying. So going 2, 4, 6, 8, 10, 12, you're just adding 2 every time.
Yeah, but not only with even numbers.
Okay, so if I had started with 3, 5, 7, it would have
Yeah.
been 9. I see what you're saying. Okay, yeah. Okay, anyone have anything different than that? The actual rule I was thinking of is just that the numbers have to go up. That's it. because the numbers have to increase. So you could have, it was 2, 4, 6, you could have put 7, 8, 9, 10, you could have put 7, 15, 305, and I would have said yes, because the numbers are all going up. Did anybody guess that rule? Okay. So this is a really good example of confirmation bias, because basically what you did, as soon as I put 2, 4, 6 up there, it's really easy to just think like I'm adding 2 or I'm counting by even numbers. And so your brain thinks like, okay, I figured it out, so I'm going to write down something that confirms that. I'm going to write down something that confirms my hypothesis, and then I say yes to that, and that's like more evidence for you, like, yeah, I'm right, I got it. The better thing to do would have been to try to write something that doesn't fit that rule. So if you thought the rule was I'm counting by 2s, then you should have written down a rule where I'm counting by 1 or I'm counting by 3. And then if I say no to that, then that still supports your hypothesis. But if I say yes to it, then all of a sudden you've ruled out your hypothesis. And you figured out, like, maybe I'm wrong, and I need to come up with a different rule, right? People do not like to think that they're wrong. Nobody does. Nobody likes to feel like they're wrong. Everybody wants to feel like they're right all the time because it feels good to be right, right? How many of you have ever, been in an argument with someone and you realize at the end that you're wrong, and that felt good? Anybody? How many of you have been in an argument with someone and they realized that they were wrong and you were right, and that felt good? That feels good, right? Whenever you win an argument and you know you're right. So we really like feeling right, so we will seek out anything that proves to us that we're right about things. And if something makes us feel like we're wrong, we're going to ignore that. We're going to avoid it as much as possible. So that plays into, if I told you to give me examples of that, anybody think of examples of where confirmation bias comes in real life situations? Yeah, Aiden. Statistics? Is that what you said? Can you elaborate, maybe a little more specific, what you mean?
Looking at specifics and statistics to support hypothesis and something broader statistics.
Yeah, so if you maybe have a view of the world or something, you have a belief that you hold, you might try to go to find statistics that support that view. Is that kind of what you're saying? Yeah. And part of the issue right now, it's I could think of just about any theory or idea, and I guarantee you I could find something on the internet that supports that. I could come up with just the most off-the-wall crazy theory I could possibly think of, and probably there's someone online who has said the same thing or has the same thought or put something out there that I could say confirms that thought, right? So it's very easy to fall into little traps on the internet where you get into a bubble of people who have the same opinion or view as you, and they just confirm your beliefs and confirm your beliefs, and then those beliefs grow stronger, and they're harder to change. They become less flexible because you're constantly engaging in this kind of confirmation bias, right? So anything that's even remotely controversial you can think of, politics, religion, etc. Did you have something?
I was going to say religion.
Yeah.
Because
So,
although, I'm not saying that I'm not religious, but that is a confirmation bias.
right. Yeah. So, that's where a lot of superstitions come from, is something will happen just by chance, but people notice a relationship maybe that's just spurious, that has nothing to do with anything, but people notice that, and then they notice it every time it happens again, right? I'm trying to think. There's a study they did with, I want to say crows, it could have been rats too, they've probably done it with multiple animals, where they have a food dispenser that just dispenses food at random times. So it just shoot out food just at random times of the day or whatever. And certain animals would develop these behaviors where if they happen to do something right before the food came out, they happen to be standing in a particular corner, or maybe they were scratching in a particular part of the cage or whatever they happen to be doing right before the food came out, they will start doing that behavior over and over again. Because they develop this kind of superstition that, if I'm digging over in the corner, the food shot out. It did it that one time, so I'm going to keep digging in the corner. And then every time they dig in the corner and food comes out, that reinforces that belief, right? But every time they dig in the corner and the food doesn't come out, they just ignore that because they're also engaged in confirmation bias. That's how we get a lot of superstitions and stuff like that. We just had the Super Bowl yesterday. Any of you, either yourselves or know anyone who has superstitions around sports, who thinks I need to wear a jersey on sport day or whatever. Yeah, so we all probably know that person that's they have some ritual they got to do on the day of whatever their sport is because they think that'll help their team win. That's, again, the superstition that often comes from confirmation bias. Maybe there was one time they wore that jersey, their team won, so now they form this belief, and then anytime something happens that meets that, that's confirming their belief, and then they just ignore every time that something different happens, because again, they don't like to feel like they're wrong. So there's a billion places where confirmation bias comes up. It's something that we're all very prone to, and that we can't escape. Another thing I'll say about these heuristics, just knowing about them is not enough to like get rid of them, right? I've been studying these heuristics and biases forever, and I still am definitely prone to falling to some of these biases at times. Everybody is. There's no escaping it, really, unfortunately. Okay, so we talked about representativeness, confirmation bias, hindsight bias. Again, I don't have an example for it because it would require like more time to set up. But hindsight bias is basically where you think that you or someone else should have had more information in the past that would have been impossible to have. So maybe a really tragic example, but it's like current top of mind. There was just this horrible earthquake in Turkey and Syria where like over 30,000 people have died at this point, right? Horrible thing that happened. And hindsight bias is people now saying, well, we should have done X, Y, and Z to prevent this from happening. We should have done this and that to try to make, the building stronger or whatever. But they're only saying that now because now we have the information that we have now, right? We have the information of the earthquake happening, where it happened, how it happened, why it happened. But there's no way we possibly could have had that information 6 months ago or a year ago. But we think like we should have known more in the past than we possibly could have. So hindsight bias is where we think that current information somehow should have been available in the past.
My mom likes to say, coulda, woulda, shoulda.
Yes, yeah, exactly. That's a very good response to hindsight bias. All right, and then the last one. So the last one we gotta get a little bit more mathematical, which my brain with my ear infection is not in that state today. So we'll see how good of a job I do explaining this one. But base rate fallacy is essentially where we ignore the base rate of something. I'll give you an example and then I'll try to explain it in a way that makes sense in a second. So this one is relating back to the cabs. There was like a long paragraph that talked about the city has blue cabs and green cabs, and Julie saw this accident at night. She said, I think she said it was green, right? And you're supposed to give me like, what's the probability that you think the cab was actually green? So in the original paragraph, it said 85% of the cabs are blue, only 15% are green. Okay, so we're starting with a pool of only 15% of the cabs in the entire city are green. And then she says it's green, and she has this 80% accuracy that they test on her ability to like discriminate these colors at night. So how many of you, the chance that you gave was like somewhat close to 80%? Most of you? Okay. Did any of you give a number less than 80? You want to tell me what you put? 10%. 10%? Interesting, okay.
I did 50-50.
50-50, okay. Anyone else?
I did 15.
15? Okay, all right. I think it's interesting you went down to 10. I'm trying to think I don't know what you were going with that, but. Okay, so let's think about this a little bit. Most people will just say 80 straight up because they get that number that she's 80% accurate, right? But you gotta think again about like the pool of cabs that are statistically available. If only 15% of the cabs in the city are green, then the probability to begin with that she saw a green cab is 15%, right? But then we have this additional information that she saw the cab and she's 80% accurate. This one is really hard to say like what's a correct number. There's not really a correct number. I mean, there's different theories you can take to approach it mathematically. But I would say probably the most logical way to approach it would be to do like 15% of 80%. So 15% times 80%, which I don't know, if someone wants to do the math for that, you can. But that'd be what, like less than 20%, I want to say? Anyone have a calculator and want to do it? Just do 0.15 times 0.8.
About
12? So 12%. seems wrong to me. I feel like my brain isn't doing this right now. Does anybody, any like math majors, anyone who's good at math, who knows like what the proper approach is? Because it feels to me like it should be somewhere between 15 to 80%, but maybe that's some bias that I have that's coming in that I'm not aware of. But yeah, but the point is, definitely shouldn't be 80%, right? Because you're starting with a really low probability of there being a green cap to begin with, so you've got to take that into account. So that 15% green cars, 85% blue cars, that's the base rate. So that's just like, you know, at baseline, this is how many cars there are in of these different colors. So most people, when they're confronted with something like this that has sort of complex math going on, they tend to completely ignore that base rate information. What was that?
Got put 15
Point 15? Okay. The point is definitely less than 80. Okay. I won't worry too much about the specific number. So my brain's too slow and tired today. The main place where you see this come up a lot in real life scenarios is in like medical situations. So I have another example, but it's all math based and my brain's too tired to like function that way today. So I'll just give you kind of the gist of it. So let's say, for example, that there's a really rare disease, something that like, you know, less than 1% of the population ever gets. And you go to the doctor because you've got some symptoms and you get a test and you test positive for that disease. Okay? And let's say the doctor tells you that this test has like a 95% accuracy rate. All right? So let's say the disease exists in 1% of the population. You've gotten a positive result. The doctor tells you this has a 95% accuracy rate. What would you think the probability is that you actually have that disease in that case? Especially if you hadn't learned anything that you're learning today.
Pretty small.
What's that?
Pretty small.
Pretty small? Would you think that prior to learning what you learned today, I guess? If you hear that this test is 95% accurate,
No, you think you have it.
yeah, right? You would probably think there's a 95% chance that I have this disease, is what most people would think. You get this test, doctor tells you it's 95% accurate, you're probably going to think you have it. But that's because most people are ignoring that 1% base rate, right? You're taking that into account now because I've already told you about it.
Okay.
So you're doing a good job, which is great. You're learning from this class. But yeah, but most people, if they have never heard this information before, they're going to ignore that base rate information and they're going to fixate on the accuracy of the test. But again, like if you do the math, I think I have it all like laid out here. We don't have to work through it because again, it's going to hurt my brain. But the probability that you actually have the disease, if it's like less than 1% in the population and it's a 95% accurate test, is still only like 2%. There's basically a 2% chance at that point that you actually have the disease. So that's why they often say, if you get a test for a rare disease like that, you get a positive result, you always want to get a second opinion. You always want to get at least a second test to see if it comes out positive again, ideally from a different doctor, a different lab, because they may be making mistakes, there may be errors that are feeding into that, etc. So yeah. And then another kind of medical like setting is our understanding of how different treatments work. So this applies most recently to things like vaccines, but this could apply to like medications, pretty much anything. So there's a lot of misinformation about like the COVID vaccine, for example, where people would find examples of someone who had gotten the COVID vaccine, but then went on to get COVID. And people would say, oh, that's an example of, you know, this vaccine isn't actually effective. But again, it's kind of ignoring base rate. So if you have a large population of people who are getting vaccinated, and then a very small portion of the population who's not getting vaccinated, then that's our base rate that we're starting with. We have 80% here are vaccinated, 20% are unvaccinated. And let's say from that, you know, 2 in each pool get infected. 2 of these people get COVID, right? In the headlines, you might see this part. You might see 2 people out of 20 people who got the COVID vaccine got infected. This isn't an effective vaccine, but you need to compare the proportions instead of the absolute, right? So 2 people, sorry, I was looking at the wrong thing. It would be this that would be in the headlines. The people who got vaccinated and still got infected. My brain's not working today. You guys get what I'm saying? Even though I just said that backwards. Everybody following me? So, but again, you gotta compare proportions. So 2 out of 80 is a very small number. 2 out of 20 is what? That's 10%. 2 out of 80 is less than 10%, way less than 10%. someone do the math on that. That'd be what, like 4% or something? Something like that. So we got 4% of people that are vaccinated getting infected, whereas 10% of people who are unvaccinated are getting infected. So the vaccine is much more effective in that case than not getting vaccinated, is the point, right? But again, if you're ignoring the base rate information of how many people are vaccinated and how many people are not, then it can start to seem like there's a problem with the vaccine. And again, this could apply to anything, flu vaccine, medications. If someone puts out a medication to treat depression and it works for some people take it and it doesn't work, you might get this false sense that like there's something wrong with the medication, but you got to look at the original base rate of like how many people are taking the medication and it is effective versus how many people are not taking it